Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
What would you do if something from another star appeared in the sky out of the blue? Astronomers saw just that in 2017. A strange, shiny object speeding through our solar system. It was spinning and going faster than we thought space rocks should. The scientists said they knew, but did they really? Because what they say now doesn't sound as good as it does. Stay with me. You're going to want to hear this. What made Oumuamua so weird? They thought Oumuamua might just be another safe comet or asteroid passing by when they first saw it moving through the solar system. But it got weirder as they looked into it more. Scientists didn't know what to think about this thing based on the rocks and ice balls they've seen many times before. And each new thing that was seen made the puzzle even bigger. To begin with, there was its shape. Asteroids are usually roughly round or slightly curved, but Oumuamua seemed to have a very strange, almost impossible shape.
Now, rather than call this by its unwieldy catalog name, we briefly called it Rama.
It looked like it was either shaped like a cigar, long and thin, or a pancake, flat and wide, based on how it mirrored sunlight as it moved through space. No matter what, its size was unlike anything that had ever been seen before. Most things in space have an axis ratio of no more than 2:1. The number for Oumuamua was more like 6:1, which means it was either ridiculously long or incredibly flat. We don't know of any natural thing that can take on such a strange shape and live for billions of years in space between stars. Then there was the falling. Oumuamua wasn't turning easily, like a top that is balanced. Instead, it was shaking all over the place.
It moved too fast to be bound to the sun. Very first object that we have found coming to us from interstellar space, from other places.
Like a glass fragment being thrown through the air. It's strange that the falling didn't slow down or change much over time. Usually, a comet's outgassing or even small impacts would have changed its spin, but this thing kept moving in a steady, random way, as if nothing outside of it were affecting it. The fact that it was shiny made things even more confusing. It wasn't very big, no more than a few hundred meters across, but it was bright. In order to do that, it had to have a very high albedo, or reflection, compared to other asteroids. It looked like shiny metal or new ice, which is strange for something that has been moving through the dark, dusty space between the stars for millions of years. The weirdest thing about it might have been how it moved. When Oumuamua flew away from the sun, it didn't slow down as much as gravity would have suggested. It was going a little faster, though, like something was pushing on it that couldn't be seen. This is known as non-gravitational acceleration, and comets do it all the time. When comets get hot near the sun, the ice on their surfaces sublimates or melts and turns into gas. Jets of this gas work like tiny thrusters. Although Oumuamua didn't leave any gas, smoke, or dust behind, it didn't do anything we'd expect from a comet. As it turned out, the most sensitive instruments on Earth and in space did not find any proof of any outgassing. Every possible answer was ruled out one by one. It wasn't acting like a comet because it wasn't letting gas out, which is what gives comets their tails and jets. It wasn't an asteroid either, because the way it moved and looked didn't match any known hard body. It wasn't just strange, it went against everything we knew about space rocks. That's when Harvard scientist Avi Loeb made his controversial claim. It might not have been a rock or a comet after all. It could have been something fake.
We don't see that in our solar system. None of the asteroids in our solar system look like that. So it's very puzzling how it could have obtained this shape.
Loeb thought that Oumuamua might be a light sail, meaning that it was a thin, flat object that could be moved by starlight. We have already started trying light sails here on Earth. They work by using photons to push a very thin sheet of reflective material through space. If Oumuamua was made by a society far away and sent into interstellar space, that would explain its strange shape, high reflectivity, lack of outgassing, and the strange acceleration it felt when sunlight hit its surface. People were very excited about the idea, and scientists were very divided on it. Some people laughed it off right away, saying that the simplest answer had to be natural. Others agreed that it wasn't so easy to rule out. But one thing was clear: no natural theory could fully explain all of Oumuamua's actions. Every answer left some things out. Each model failed, and as more information came in, the questions kept coming up. It wasn't just one thing about Oumuamua that seemed strange. Everything about it seemed to go against what we thought we knew. It was the form, the falling down, how shiny it is, the impossible speed up. If any of these were explained on their own, they would have made a picture of something that didn't fit easily into any known object category. It was like the universe had thrown a puzzle in our yard and challenged us to figure it out. That question leads us to the next part of the story, a supposed elegant solution that was quickly accepted by scientists and said it solved all the problems, but created new ones as well. There was an idea about hydrogen comets that seemed too good to be true. Let's look into it more. The hydrogen comet theory. A lot of experts didn't like the idea that Oumuamua's strange behavior could have been fake when they studied it. They wanted something easy, normal, and that wouldn't change what they had thought about the universe for decades. Then an idea came up that seemed to fit all of those criteria: the hydrogen comet. The main idea behind it was that Oumuamua was just a big block of frozen hydrogen that slowly turned into air as it moved through our solar system. The idea was that since hydrogen gas can't be seen by telescopes, no outgassing was seen, even though it was speeding up like a comet. This thought spread very quickly. People who liked it thought it was clean and classy. It wasn't necessary to come up with any new strange materials. Aliens didn't need to be involved in making light sails. It was just a natural block of ice that had been broken off of a faraway, cold world and thrown into space between the stars. It was easy to see why it was appealing. It gave a reason based on known physics and kept the secret in nature, not technology. Many people saw the hydrogen iceberg as the last piece of the picture. But the hydrogen comet idea started to fall apart as soon as people looked more closely, no matter how good it looked at first. Avi Loeb quickly pointed out the problems with the light sail theory, which had already caused some people to raise an eyebrow. What he said got right to the point. Hydrogen ice is so fragile and easily broken that it would not have made it through interstellar space. A block of pure hydrogen would have broken down long before it got to our solar system, because it would have been hit by dust grains and cosmic rays. The idea made us think that Oumuamua not only formed as a pure block of hydrogen, which is something we have never seen happen, but also made it all the way here without any damage. That alone made it hard to believe. It then got to the numbers. A hydrogen iceberg might have been able to make it through the trip, but its rate of melting didn't match the acceleration that was seen. It was impossible for the gas pressure from hydrogen evaporation to explain how fast Oumuamua moved. You could change the size or the assumptions about the albedo, but it never quite lines up right. The idea that it was meant to be simple and beautiful wasn't either, as it turned out. It looked like a patchwork solution that was put together more to avoid tough questions than to really fit the facts. There was also another problem. There was no proof from the real world that these hydrogen blocks existed. Astronomers have looked many times at molecular clouds and icy planets, but have not yet found a single body made of solid hydrogen. Hydrogen is the lightest element in the world, and the theory says that it shouldn't be easy for it to form dense, solid chunks. Not only was it unlikely that the hydrogen iceberg would make it through cosmic space, but it was also only a guess how it could have formed. Even though there were so many problems with the theory, it was quickly and loudly accepted. The mystery was said to be answered in the headlines. They thought it was a very smart answer. The alien light sail idea was quietly thrown out, because it was thought to be unrealistic and meant to make people feel good. It was comforting for scientists to see the hydrogen iceberg. It let everyone think that Oumuamua was just another strange rock that was formed naturally and not proof of something we don't fully understand yet. The news outlets did the same thing, running story after story about the natural comet theory without talking about the major problems with it. That wasn't the end of the story, though. While the hydrogen theory was being looked into more, a new answer was ready in the wings, another natural hypothesis, this one with even more details and just as much support. It finally answered the mystery for a lot of people. But for people who were paying attention, it only made things more confusing. Now, we'll talk about the next part, which is the nitrogen Exopluto model. The Exopluto fragment model. Scientists needed another natural reason for Oumuamua to keep it in the not alien category when the hydrogen comet theory started to fall apart. Jackson and Desch, two planetary scientists, then came up with a new idea. Maybe Oumuamua was a piece of solid nitrogen ice that had been broken off of a world like Pluto far away and then sent racing through interstellar space. At first glance, this idea seemed to be even better than the hydrogen model. Their idea started with a simple fact. There is nitrogen ice in our own solar system. Pluto's surface is made up of huge areas of frozen nitrogen, just like Triton, Neptune's moon. Unlike the hydrogen iceberg, which is just a theory, nitrogen ice is known to form in big sheets on cold, faraway planets. A big impact on one of these frozen worlds in a different star system could have sent a chunk of nitrogen ice into space, where it would end up finally arriving here on Earth. Jackson and Desch thought this might have happened about 500 million years ago in a young star system in the galaxy's Perseus arm. This piece of nitrogen would have been shaped by time and radiation as it moved between stars. Cosmic rays would slowly wear away at its surface, changing its shape and making it thinner. Sublimation, the process by which ice turns straight into gas, would remove even more material. The piece would get thinner and longer over millions of years, like a bar of soap chipping away into a thin slice. By the time it got to our solar system, it would have lost most of its original mass, leaving behind a thin, shiny piece that looked a lot like Oumuamua. The nitrogen model also had a way to explain how bright Oumuamua was. The bright surface we saw through binoculars might have been caused by nitrogen ice, which has a high albedo similar to what is seen on Pluto and Triton. And, unlike hydrogen ice, nitrogen ice is much more stable over long trips between stars. This means that it is at least possible for such a piece to have survived complete for hundreds of millions of years. The most interesting thing about Oumuamua's behavior was how it sped up strangely as it left the sun. This theory could explain that, during its close pass, nitrogen would have sublimated from the surface, giving it just the right amount of thrust to explain the small but obvious change in its path. While water or carbon dioxide would have made comet tails that could be seen, nitrogen would have sublimated neatly and undetectably, leaving no clear signs of outgassing. On top of that, the surface would stay cold enough through evaporation to stop the kinds of thermal signatures that would have been easy to see with infrared cameras. For many scientists, this seemed to explain everything. The shape, the speed, and the ability to bounce light, all with a known substance and a believable past. However, this plan had its own problems, even though it seemed good at first. For one thing, it depended on a lot of very specific things happening at the same time. It had to be just the right time. The nitrogen piece couldn't have been too old, or it would have broken down long before it got to us. Its path had to stay the same so that after hundreds of millions of years, it would cross our solar system without hitting anything or breaking apart. When you think about how big and chaotic the galaxy really is, that level of fine-tuning seemed like wishful thinking. Another problem is that there is still no direct proof that these kinds of nitrogen fragments appear in other places. Pluto and Triton show that nitrogen ice is possible, but we've never seen anything like Oumuamua before, and we still haven't seen anything like it since. It's still just a guess that nitrogen bits are scattered around in space between the stars. For a theory that is supposed to give a simple, natural answer, it is based on ideas that have not yet been proven. Why scientists really hate the alien hypothesis. From the start, Oumuamua's strange behavior seemed to call for bold thought. An object with a shape no one had ever seen before, that reflected light like shiny metal and sped up without any obvious gasping out. It was the kind of puzzle that should have led to all possibilities. The idea that Oumuamua might not be natural at all, on the other hand, was not taken seriously by most experts. These days, bringing up aliens is almost worse than being wrong in the world of current science. Many astronomers and physicists think it is irrational, silly, or even unscientific to say that an unexplained finding could be proof of technology from other planets. People put the alien theory in the same group as superstition, sightings of Bigfoot, and ideas about ancient astronauts. It's seen not only as impossible, but also as funny, a taboo that must be avoided at all costs. Part of the reason is easy to understand: money. Grants and university appointments are what researchers rely on. These are given out based on reputation and how well they fit with existing ideas. If someone said that Oumuamua might not be real, they might be seen as sensational, which could hurt their career and reputation. For young experts in particular, it could be a waste of time to even ask the question. This unspoken pressure stops people from talking freely about the alien theory and keeps it out of serious academic circles. A response from Roman Rafikov, a well-known and respected astronomer at Cambridge, says it all about this bias. When asked if Oumuamua could be a light sail made by a different civilization, Rafikov joked that any explanation that involved aliens was the same as saying divine forces were to blame. He said that the alien theory was the same as a religious tale, not because of proof, but because of ideology. This kind of statement shows how deeply rooted the rejection is. There are a lot of similarities with history. The Catholic Church fought hard against Galileo's ideas of heliocentrism, which said that the sun is at the center of the solar system in the 1600s. The Church stuck to geocentrism not because it was true, but because it fit with their view of the world. Galileo was made fun of, criticized, and even put under house arrest for just writing about what he saw through his telescope. The same kind of institutional orthodoxy rules over scientific organizations today. It is seen as folly to say that aliens could explain something we don't understand, even if the evidence fits. Truth, on the other hand, costs something. If scientists rule out all options right away, it could stop being about discovery and more about keeping dogma alive. When scientists stick to what they know works, they kill the innovation and curiosity that move things forward. People don't try even good ideas because they're afraid of being laughed at. It swaps thought based on facts for a type of groupthink that values safety over truth. Avi Loeb's light sail hypothesis is so important not because it's proven, but because it lets the facts lead it where it may. Loeb said that a thin, flat, mirrored object being pushed by sunlight could explain all of Oumuamua's strange traits, including its shape, speed, lack of outgassing, and even the way it tumbled. The idea is just a guess, but so are the natural models that are being put forward to replace it. Some people think that the light sail idea fits the data as well as, or better than, theories about strange ices or nitrogen shards. Still, scientists didn't believe it, not because the facts didn't support it, but because it made them feel bad. Instead of putting the idea to the test, they made fun of it and said the mystery was solved with theories that still don't answer all the questions. Science isn't meant to work like that. The story of Oumuamua shows a troubling aspect of how we deal with the unknown. Scientists should ask what the evidence says, but instead, they ask what the evidence lets them say without putting their careers at risk. That will lead to lost opportunities and a lack of progress. In this case, we are denying real options just because they don't fit neatly into what we know now. In reality, though, We already know that we're not alone in the world. We don't know that we're in direct contact with other intelligent beings, but we do know that life and intelligence are possible in other places. There are so many stars and galaxies in the world that it's hard to imagine. Each galaxy has its own planets. It is both cocky and not scientific to think we are the only ones experiencing these things, and to think that any signal or object we can't explain is just normal. So why do experts dislike the alien idea so much? It makes them face their own limits, which is good, because it makes us question the idea that we already know everything about the universe, because it tells them that being humble is a part of discovery. As Galileo showed 400 years ago, our place in the universe may be smaller than we think. This is perhaps the most important thing about it. It dares to say that we are not the center of everything. In fact, this refusal shows the darker side of scientific agreement. The risk of calling a mystery answered too soon and stopping people from asking questions before the answers are really clear. We need to look at what happens when agreement turns into tyranny to see how dangerous that can be. The tyranny of consensus and its danger. One thing has happened over and over again since Oumuamua came through our solar system. Everyone was quick to say that the puzzle was solved. The hydrogen iceberg idea was the first one. As that broke down, the nitrogen shard model took its place. Now, even more recent studies have brought up the idea of strange combinations of water and ice. Every time, the statement had the same cocky tone, as if the question had been answered for sure, and there was no need for any more guessing. But none of these so-called answers have really worked. Each one is based on theories that haven't been proven yet. Each one leaves holes that no one wants to fill. Each one has been praised less for what it shows and more for how it keeps scientists from coming to a conclusion they don't like. This desire to agree on a natural theory is more than just scientific caution. It's a sign of what we can only call the tyranny of consensus. It seems like many people in the field would rather protect an orthodoxy than keep the question open and look at all the possible answers. It seems like Oumuamua's biggest threat wasn't to our world, but to what we think we know about it. Because of this, every natural answer, no matter how weak, was seen as a win. And that's why the idea of alien technology, which fits the evidence just as well in many ways, was called fantastical. The media only makes this effect stronger. Headlines are meant to comfort rather than teach. Many times, news stories said that the puzzle was solved, but they made fun of the alien theory. A lot of phrases are out there, like "not a spaceship" or "scientists debunk alien theory." A lot of the time, these pieces don't talk about the problems with the most popular models. For example, they almost never say that all of Oumuamua's traits have a natural explanation. The message to the public is clear. To even think about alien technology is to go into the realm of conspiracy theories. We should not think this way, because it is bad for science in general and for our understanding of Oumuamua. When we quickly rule out outlier theories, we miss opportunities that could lead to real breakthroughs. In the end, every big scientific finding began as an oddity. People used to think that plate tectonics was just a theory. People made fun of the idea that germs can make you sick. It was debatable at the time that other galaxies were found. Each time, the view that most people agreed on was safe, but it was also wrong. The fact that these natural solutions have been called elegant makes things even worse. Elegant answers that make sense of the data without adding extra work are often seen as beautiful in the scientific community. For example, the nitrogen shard model was called beautiful because it used well-known materials, made sense of how things worked, and matched what was seen on the surface. But being classy isn't enough. There are times when an idea is both beautiful and wrong. If you don't test your ideas thoroughly and aren't open to others' ideas, beauty is just pretty words. Science isn't meant to work like this. At its best, Science is a process of always asking questions, testing every idea, and being ready to change or even throw out long-held beliefs when the evidence calls for it. Being skeptical is good because it keeps us from judging things too quickly. Skepticism turns into dogmatism when it's used in an unfair way, to shut down some ideas while letting others float. For Oumuamua, doubts about alien technology have been so strong that they are almost religious, because real doubt should work both ways. It should demand that natural solutions be proven just as thoroughly as more hypothetical ones. It should question every model in a tough way, no matter how easy or natural it seems. And there should be room for doubt when there isn't a clear answer yet. When the answer brings no comfort. No matter how many problems it has, the nitrogen ice theory is still the most popular way to explain Oumuamua. It makes sense, it's normal, and it keeps us from having to think about the uncomfortable idea of alien technology. But even if Jackson and Desch are totally right, even if Oumuamua is just a piece of frozen nitrogen thrown from a faraway Exopluto, the result is still not very satisfactory. In fact, it should really bother us. If Oumuamua was a piece of nitrogen, then interstellar space is full of other pieces like it. There may be a huge number of fragile, fast-moving objects swirling between the stars, ready to collide with worlds like Earth. If these bits are as common as the nitrogen model says they are, then Oumuamua wasn't a one-in-a-million fluke. It was just the first one we saw. What's wrong is that we only saw it as it was going. It passed us by before we could really study it, and we didn't even see it coming. When it comes to tracking things like Oumuamua, our detection tools are completely broken. It took us a while to find it because it was already leaving the solar system and no longer close to the sun. We wouldn't have known about it at all if its path had brought it even a little closer to Earth. Also, keep in mind that even small things moving at speeds close to the speed of light carry a lot of energy. What would happen if one hit Earth? It could be terrible, but we'd never see it coming. Besides the risk, there is also the chance we missed. The science community missed a chance to look into a much deeper question when they quickly threw out the idea of aliens. How about if it wasn't just a rock? How about if it were a piece of tech? No one was willing to hold on to that chance long enough to test it, so we'll never know. Being intellectually shy in that way doesn't just make it harder to understand. It also makes us less ready for the unexpected. That might be the scariest lesson of all. People's fear of being wrong or going against what most people think seems to make us less interested in new things. We don't embrace mystery and follow every lead, no matter how strange it is. Instead, we turn to explanations that are known to us. But ignoring scary options is a lot more dangerous than looking into them. Stay curious and never stop questioning what's out there. Like, share, and subscribe for more. And don't forget to click on the next video popping up on your screen right now.